Welcome to Get Your FRQ On. This question is from 2009, Form B, and it's question 3. In the question stem, we've got a continuous function f, which is defined on the closed interval from -4 to 6. We're told that the graph of f consists of a line segment and a curve, and the curve happens to be tangent to the x-axis at x equals 3. We're also given that on the exclusive interval, or open interval from 0 to 6, the function f is twice differentiable, and it has the property that the second derivative of f is always positive on that interval. In part A of this question, we are asked if f is differentiable at x equals 0 and to use the definition of the derivative using one-sided limits in order to reach our conclusion. First, we note that from the graph, it's easy to tell that f is not differentiable at x equals 0. But we need to justify that conclusion, so we're going to analyze the one-sided limits. So first, if we look at the limit as x approaches 0 from the left of f of x minus f of 0 over x, that turns out to be positive 2/3. If we then look at the limit as x approaches 0 from the right of f of x minus f of 0 all over x, we can't tell exactly what the value of that limit is, but it's pretty obvious from the graph that it is negative. And since 2/3 is not going to be the same as a negative number, we conclude that the limit as x approaches 0 from the left of f of x minus f of 0 over x cannot possibly equal the limit as x approaches 0 from the right of f of x minus f of 0 all over x, and so therefore f cannot be differentiable at x equals 0. In part B of this question, we are asked for how many values of a on the interval closed at -4, open at +6, is the average rate of change of f on a to 6 equal to 0. So the average rate of change of f on the interval from a to 6 will equal 0 whenever f of a equals f of 6. We can tell from the graph of f provided that f of 6 is equal to 1. And we can also tell from the graph of f provided that f of a is equal to 1 somewhere near x equals -2, and again somewhere near x equals +1. So we can tell that there are two values of a between -4 and 6 such that the average rate of change on the interval from a to 6 is equal to 0. In part C of this question, we are asked if there's a value of a between -4 and 6, such that when we apply the mean value theorem to the interval from a to 6, that there is a value of c between a and 6, such that f prime of c is equal to 1/3. We're given in the question stem that f is twice differentiable on the interval from 0 to 6. So we can use this to conclude that f is definitely, singularly differentiable on the interval from 0 to 6 as well. And since the graph of f is tangent to the x-axis at x equals 3, we know that f of 3 is equal to 0. F of 6 minus f of 3 over 6 minus 3 comes out to +1/3. So by letting a equal 3 and applying the mean value theorem to the interval from 3 to 6 does guarantee the existence of a value of c between 3 and 6, such that f prime of c is equal to 1/3. In part D of this question, we define the function g of x to be the integral from 0 to x of f of t dt over the interval from -4 to 6, and then asked to determine on what intervals g of x is concave up. First, we note that by the fundamental theorem of calculus, the derivative of g of x is f of x. Furthermore, we can conclude that the second derivative of g is the first derivative of f. And we know that the function g will be concave up when its second derivative, which is the first derivative of f, is positive. Based on the graph of f provided to us, f prime of x is positive on the intervals from -4 to 0 and from 3 to 6. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.